I am Veekshitha B V, Assistant Professor, Department of Optometry, Yenepoya School of Allied Health Sciences. Today I am going to present the topic lasers. So to start with, we'll see at the end of the session, you will be able to describe laser, including the concept of stimulated emission and population inversion, explain the requisites of laser system, elucidate the basic laser principle, list the properties of laser, and explain the use of laser in real-world applications. So the word laser is an acronym for light amplification by stimulated emission of radiation. It is a powerful device which emits highly coherent monochromatic beam of light. The laser has many superior features compared to conventional light sources. This concept was first introduced by Einstein in 1917 and later T.H. Mayman demonstrated the first laser, the ruby laser, in the year 1960. So before going to the principle of lasers, we'll just see the terms ground state and excited state. The lowest energy level for an individual atom occurs when its electrons are all in the nearest possible orbits to its nucleus. This energy level is called the ground state. So in the first image, you can see the electrons are represented by the green color. So they are revolving around the positively charged nucleus. So the lowest state in which the electrons are present is the ground state. When a photon is incident on those electrons, they move to the higher level. So that is the excited state shown in the figure 2. And these excited states are not stable. As the electron drops from higher to the lower energy level, the extra energy is emitted as light. Next is the method of interaction of radiation with matter. The production of laser is a consequence of interaction of radiation with the matter. So the radiation interacts with matter in 3 ways. The first one is induced absorption. The process of absorption of the incident photon by an atom and hence its excitation to the higher energy state is called induced absorption. So in the figure you can see it can be shown that consider a system consisting of n number of molecules, and let us assume that each atom or molecule has 2 energy levels, the higher energy level and the lower energy level. The energy of the lower energy level represented by E1 and the higher energy represented by E2. The electrons, molecules or atoms present in the lower energy level, when it is incident by some photon of frequency nu with the energy h nu as the difference between the levels E2 and E1, it gets excited to the higher energy level. This is called as absorption. It is also referred to as stimulated absorption. Next is the spontaneous emission. The process of emission of a photon of suitable frequency by an atom due to the transition from a higher energy state to a lower energy state without any supply of external energy is called spontaneous emission. So the first image here shows an electron in the E2 state, that is an excited atom. So when it undergoes de-excitation to the ground state, it emits an photon h nu with energy h nu. So this photon emitted due to the spontaneous emission are always incoherent. The third method is the stimulated emission. This process of emission of a photon by an atom in the excited state due to the incidence of an identical photon of same energy on the atom and hence the transition of the electron to a lower energy level is called stimulated emission. So here in the image, an excited electron is present in the E2 state which is made to incident and photon on it. So it gets de-excited, absorbing that energy, emitting certain photons, and these emitted photons will have same energy, frequency and are in phase. Also, the stimulated emission can be referred to as producing amplification of the incident light. This amplification process is employed by the lasers also. and the frequency of the emitted photon can be given by the equation Eg is equal to h nu, which can be written as hc by lambda, or lambda is equal to hc by Eg. Here Eg is the energy gap, that is the difference between E2 and E1 level. Lambda is the wavelength of the photon, c is the velocity of light in vacuum, and nu is the frequency. So to see the conditions for laser action, the first one is population inversion. It is a state in which the number of atoms in an excited energy state is more than the number of atoms in the ground state. So in the image, you can see the first image where N1 and N2 represent number of electrons in the state E1 and E2 respectively. And in the first image, we can see the N1 is greater than N2. That is, the lower energy level is highly populated compared to the excited or the higher energy state. So according to Boltzmann distribution function also, any normal system has to obey this property, that is N1 should be greater than N2. But in population inversion, it becomes reversed. The population of lower energy becomes lesser compared to the higher energy states. Next is the metastable state. It is an intermediate energy state between an excited state and the ground state of the atomic energy levels, in which the atoms stay for a longer period of time, that is in the order of 10 to the power minus 2 to 10 to the power minus 3 seconds. It is called metastable state. So consider some electrons to be in the ground state. When they absorb energy, they get excited to the higher energy state, and immediately they return back to the ground state because the lifetime of the excited state is very small, that is in the range of 10 to the power minus 7 seconds. So no population inversion is achieved. Suppose if there is a metastable state in between excited state and ground state, some of the electrons get accumulated in the metastable state for a longer period of time. That is, the lifetime of this electrons in the metastable state is very large compared to that of the excited state in the range of 10 to the power minus 2 to minus 3 seconds. So from the metastable state, when the electrons after finishing their lifetime, they de-excite, producing laser. So for any system to undergo laser action, this metastable state is very necessary. Next is methods of achieving population inversion. In order to achieve population inversion, we need to supply energy to the laser medium. The type of energy source used mostly depends on the laser medium. Some of the commonly used pump sources are optical pumping, or that uses optical energy for exciting the molecules from the lower to the higher energy state. Example, xenon flash lamps etc. are used. Next is the electrical pumping. Here electrical energy in the form of electrical discharge or even electric current is used for pumping. Next is heat pumping or thermal energy, where heat energy is used to achieve this population inversion. The other type is chemical pumping, where chemical energy is used. That is, during some chemical reaction, some of the reaction will liberate an excited molecule, and this excited molecule can be used for pumping. So these pumping sources are not only used for population inversion but also to undergo stimulated emission. So next is the requisites of a laser system. The laser consists of an active medium or the laser medium, then pumping source and the resonator cavity. This active medium or laser medium, it is a material medium in which all this population inversion and the lasing action takes place. So examples for this active medium are helium neon laser and carbon dioxide laser. Those consists of mixture of gases as the active medium. Then in semiconductor lasers, they consist of semiconductors as the active medium. The second main component is pumping or the energy source. The process of exciting atoms from a lower energy state to a higher energy state by supplying energy from an external source is called pumping. The source that supplies the energy to the laser medium is called the pump source, and this supplies sufficient amount of energy to the laser medium through which the electrons can be excited from the lower energy to the higher energy state. As a result, we can achieve population inversion in the laser medium. Examples of energy source as discussed earlier can include electric discharge, light from another laser, chemical reactions and flash lamps. Next one is the resonant cavity or resonator cavity. It is an arrangement used in a laser device to increase the emitted photon energy density, and this consists of two mirrors fixed on the either side of the active medium. Here one of the mirror is completely silvered, which contributes to the reflection of the emitted photon, and the other one will be partially silvered, and it acts both as a reflector and exit for the laser beam. So to see the principle of laser action, here you can see three images. So in the first figure, we can see, let us consider an atomic system which consists of three energy levels with energy E1, E2 and E3, where E1 is the energy of the lower energy state, and E2 is the metastable state, and E3 is the energy of the higher energy state. So under normal conditions, or generally, E1 will be lesser than E2, which is lesser than E3. And let N1, N2, N3 represent the number of molecules present in E1, E2, E3 respectively. Under normal conditions, we can observe that the population of E1 state will be greater than E2 and which is greater than E3. That is, N1 will be greater than N2, which is greater than N3. So here, when a sufficient energy photon or some light is incident on the molecules of the E1 level, they get excited to the higher excited state, that is E3, as shown by the arrow marks in the first image. This is called induced absorption. So in the excited state, atoms stay for a very short time, that is 10 to the power minus 8 seconds, and then they immediately get de-excited to the lower energy state through non-radiative emission. And now when we can see that the population of the metastable state E2 in the figure 2 is greater as compared to the other two levels, that is N2 is greater than N1, which is greater than N3. This state is called as population inversion. So in a 3-level laser systems, or a system which consists of three energy levels, population inversion is achieved between E1 and E2 levels. So now in the E2 level, the electrons, after finishing their lifetime in the range of 10 to the power minus 3 seconds, they come back or return back to the E1 state through spontaneous emission. And when this emitted photon is induced on a metastable state electron, as shown in figure 3, they absorb the energy and get de-excited to the E1 level, producing 2 photons. When these 2 photons are incident or they stimulate the other 2 electrons of the E2 level, they produce 4 photons while de-excitation. So this process continues, and a large number of coherent photons can be produced. Thus, light amplification process is done through population inversion and stimulated emission method. So this is the principle of laser, how the light gets amplified. The same thing is explained in these slides. So next, looking into the properties of laser, the first one is directionality. So as compared to the ordinary light, we can see that ordinary light is, in the figure, it scatters the light beam, whereas the laser beam is unidirectional, that is, it travels only in one direction to a very large distance. Therefore, we can tell that the lasers are highly directional. The next property is coherence. The photons emitted by the laser are in phase with same energy, frequency and wavelength. Thus, they have high spatial and temporal coherence. That is, mainly the laser light photons, we can say they are always in phase with the same energy and frequency. That is the reason they are highly coherent compared to the ordinary light, which is incoherent. The next property is monochromaticity. Lasers have a high degree of monochromaticity. That is, since they emit a single frequency or single wavelength, they can be called as monochromatic light. That is, a single color. Whereas the ordinary light will be having multi-frequency and they are non-coherent. Also, they are polychromatic sources. The next property is intensity. Due to the high directionality, the intensity of the laser beams are concentrated in a small region. Thus, laser beam is highly intense. And focusability, the laser is highly monochromatic and highly directional, hence it can be brought to a sharp focus by a lens. Thus, it can be said to have a high focusability also. And these properties, these unique properties of the laser makes it useful to be applied in various applications, such as in various fields such as medicine, for certain surgeries and imaging of the tissues, and also for certain cancer treatments these lasers are used. In the communication field, the laser is used in optical fiber cables to transfer data or information through very long distances. And in manufacturing industries, for cutting and welding purposes of the metals, and also to engrave logos and designs on metals. In scientific research, certain spectroscopic methods employ lasers to identify the molecules present in certain substances, and also used in the astronomic field. In consumer electronics, we can see laser printers to give high definition printing and images, and also in CDs and DVDs to write and store the information. It is also used in defense and security for navigation or range finding, and also it can be used in directed energy weapons such as certain missiles or drones. In the field of entertainment, laser shows and virtual reality employ these lasers. So apart from this, laser finds its application in various other areas also. So to summarize, laser stands for light amplification by stimulated emission of radiation. Methods of interaction of radiation with matter are induced absorption, spontaneous emission and stimulated emission. Conditions to achieve laser action are metastable state and population inversion. The three main components of a laser system are active medium, pumping source and the resonator cavity. The properties of laser: it is highly directional, monochromatic, coherent and intense radiation. The laser finds its application in various fields due to its unique characteristics. So these are the references. Hope you have understood the concept. Thank you.